Hello students, today we are going to study about diamagnetism. Before studying diamagnetism, let us understand that there are three types of material based on the magnetism of that material, or generally metals are of three types: diamagnetic, paramagnetic and ferromagnetic. So initially we will be just studying about diamagnetism, and in the further lectures we will be studying about ferromagnetism and paramagnetism. Okay, so first it is diamagnetism, that is a type of material. But before studying diamagnetism, let us understand why there is the magnetic field inside any material. Okay, so we know that any material is made up of atoms. Okay, and atoms contains electrons in their orbital. Okay, so if atoms contains electrons in that orbital, the electrons start on moving or keeps on revolving around the nucleus, which means that they will start having a current, that is a charge that is flowing, which means that is a current around the orbit. Okay, current in the orbit, which means that this will act as a current carrying loop, which means it will act as a current carrying loop. And we also know that whenever there is a current carrying loop, it behaves as a magnetic dipole, as you have studied in our previous lecture. This current carrying loop will act as a magnetic dipole, which will have a south pole and a north pole. Is it clear till this? So this magnetic dipole is majorly responsible for magnetic moment in atom. This we are talking about just a single atom. We are talking about just a single atom. In a single atom there will be electron that will be revolving around the nucleus, which will make it a current carrying loop, and this current carrying loop will act as a magnetic dipole. And this magnetic dipole is majorly responsible for getting the magnetization in any material. Okay. Now, if this atom is kept in an external magnetic field, if this atom is kept in any external magnetic field, then there will be two phenomena. One phenomena is that it will try to align all the magnetic dipole, small magnetic dipole, in its own direction, that is of the external field. Suppose we have an external magnetic field, and here we have a dipole, a magnetic dipole, or you can say atomic dipole. Suppose there are in this different direction, what will happen? This external magnetic field will try to align all the things, will try to align all the magnetic particles inside it in its own direction. That is, it will align in this single direction. That is one phenomena. And the second phenomena, but yes, this is the major phenomena which will act on it. This is the main reason for magnetism of any material. The second phenomena is there will be induced magnetic dipole. Induced magnetic dipole means there will be a new magnetic dipole produced due to the external magnetic field. You will be studying about it in the next chapter, that is due to Lenz's force. Lenz's force. Okay. But this magnetic field is in the direction opposite to the magnetic field. It is in the direction opposite to the magnetic field. So let me show it over here. If this is the magnetic field, then there will be a new magnetic dipole created in the system, okay, or the atom, but it will be very weak. It will be very weak, and there will be very small atomic dipole, but it will be in the direction opposite to it. So which means that the first point is a major consideration, or it has major part to play in magnetism of any material, as well as there is a second part also, which is induced magnetic dipole due to Lenz's force, but it involves less, or it has very small induction. That is not a major part. Only in case that this part is missing, there are no magnetic or atomic dipole, at that time only this force will come into action. Okay, so I hope it is very clear that how a magnetism is produced in any of the material. If this is clear, then we will move towards the diamagnetism. That is our today's topic. So in diamagnetism, what will happen? Which type of substance? The magnetic moment if the magnetic moment dipole due to all the electron in atom cancel each other, then the net magnetic moment of an atom is 0. I'll show it to you. What will happen? Here all the electrons will act in a pair, will always be in pair. There will not be any single electron, which means you might have studied this in chemistry. Whenever you are studying the configuration of electric dipole or electrons in the dipole, then there are few electrons which are in this direction and other are in opposite direction, which have one has magnetic dipole in this moment and other have magnetic dipole in opposite moment, which means that both will cancel out the effect of each other, which means that in a single atom the net magnetic moment or net atomic dipole will be equal to 0. Net magnetic moment will be equal to 0. This type of substance are known as diamagnetic. Here the net magnetic dipole in each and every atom is 0 because all the electrons are in pair and they possess opposite dipole, which means they will cancel out each other's effect. So if I show you this a small atom, then there will be no magnetic dipole present in this. There will be no magnetic dipole present in it. Okay. Example is N2, nitrogen, copper, water. Okay. So in this, what will the major constituent that will create the magnetic field inside it? So first one, this is not possible because there is no atomic dipole in the matter. When aligned with, when it is kept in a external magnetic field, it does not have any atomic dipole, so it will not be aligned. So this will not be the major part for diamagnetism. The major part for diamagnetism will be this. It will produce induced magnetic dipole in each moment. Hence the material, and there is induced magnetic dipole in the atom, and the magnetic field due to this induced dipoles always opposes. If the magnetic field is in this direction, it tries to oppose the magnetic field. Okay, induced dipoles always opposes the applied magnetic field, which means that it will be in opposite direction, and if it is in opposite direction, it will be repelled. But yes, one thing very clear, this is very small. The induced magnetic dipole are very small, which means though it will be repelled, but it will be very weakly repelled. It will be very weakly repelled. Hence the material is repelled by magnetic field. Or here I can write weakly. Very weakly repelled by magnetic force. So this is the origin of magnetism in diamagnetic substance. Now if we try to look at the properties of a diamagnetic substance, then we shall study in this. Okay, I'll rub this much part as I need to explain you something during the properties. Okay, first one says the net magnetic dipole is 0. The net magnetic dipole is 0 in absence of external field. We know that in absence of external field, all the electrons cancel out the effect of each other's magnetic dipole. So in the end, the net magnetic dipole or net atomic dipole of any substance in this diamagnetism is equals to 0. The second property says they are weakly repelled in external magnetic field. Here we have seen it is mainly due to Lenz's force, and Lenz's force is the induced magnetic dipole that are created in opposite direction. If the magnetic field is in this direction, the induced magnetic dipole is produced in this direction, which means that both will repel each other. But this Lenz's force is very small, so it will be repelled very weakly. They are very weakly repelled in an external magnetic field. Whenever this substance is kept in an external magnetic field, it will be repelled but very weakly. Next thing is magnetic susceptibility zeta is negative and very small. Magnetic susceptibility is very small and negative. Okay, why it is negative? We know that M, that is internal magnetic field that is produced. Just refer the previous lecture for knowing this. M is equals to zeta H, where M is the internal magnetic field, H is the external magnetic field. Okay, so direction of both the magnetic field are opposite. If this is external magnetic field, internal magnetic field will be in this direction. Okay, so means if this is positive, this has to be negative so as to make this negative, because the direction of both the things are different, opposite. This is in this direction, this is in this direction. So to make both in same direction, this zeta needs to be negative. If zeta is negative, then and then you can get the opposite direction. Okay, this is one thing. And second thing, it is very weakly repelled, or you can say it is very weak. So the value of zeta is very small. Very small. For example, I have taken over here for N2, the value of zeta is minus 5 into 10 raised to minus 5. Minus 5 into 10 raised to minus 5, which means that it is very, very small. If external field is about 10 raised to 5 Tesla, if external field is 10 raised to 5 Tesla, then it will create 1 Tesla magnetic field approximately. When the external magnetic field is of range 10 raised to 5 Tesla, then and then it will make 1 Tesla magnetic field that is inside the conductor or inside the diamagnetic substance. Okay, I hope this much is very clear. Now there is one small exception. Exception is superconductor. Superconductor have zeta that is equals to -1, which is also a diamagnetic material. But when this superconductor is taken at very low temperature, that is about -300 Celsius, or you can say 0 Kelvin. At 0 Kelvin, this acts as a superconductor whose zeta is equals to -1, which means that at this point, if you produce the external magnetic field of 10 raised to 5, that time you will get internal magnetic field also equals to 10 raised to 5. Okay, which means that it is very highly conducted and it is a perfect magnetic material. But it is only exception for superconductor. Rest, zeta is very small and it is negative because it is in the opposite direction. Okay. Next is relative permeability mu r. Relative permeability mu r is slightly less than 1. Now we all know what is the formula for relative magnetic field, relative permeability. Mu r equals to zeta plus 1, or you can say 1 plus zeta. Now what is the value for zeta? Value of zeta is negative, which means that mu r will always be less than 1. As the value of zeta is negative, it will be less than 1. Okay, and what is the value of zeta? It is generally very small, very small, that is of the power 10 raised to -5, which means that mu r will be less than 1 and it will be very slightly less than 1 because the value of zeta is very small, which means it is approximately equal to 1 only. So it will be slightly less than 1. That is relative permeability. Next, in non-uniform magnetic field, it moves from stronger to weaker regions of the field. So what happens in this? Let me explain it with an example. So first thing is, this diamagnetism does not want any magnetism inside it because it does not have any magnetic dipole and it is very weakly repelling it. So same thing like we are studying in a class. Some students are there which don't like studying. So they will be repelling the studies or they will be repelling the lectures. So what happens when they come inside the class? They first start to sit on the first bench. फिर क्या होगा? इतना पढ़ाई तो हमसे नहीं होगा. As soon as they will get the chance, they will move towards the next bench or the behind bench. वहां पे भी बैठेंगे, सब लोग पढ़ाई कर रहे हैं. It is very difficult for me. So वो लोग क्या करें? जैसे ही चांस मिलेगा उन लोगों को मस्ती करना है तो they will move towards the back bench and at last they will try to reach the last bench of the class, which means that from the stronger studying field they have moved towards the field that is weaker in studying. So similarly here diamagnetism does not involve any magnetism or very less magnetism. So whenever it is kept inside a non-uniform magnetic field, what it will try? It will try to move from stronger to weaker region. From stronger to weaker region, as it does not possess any magnetism or it possesses very less amount of magnetism. Okay. And the last one, magnetic field lines becomes less dense inside the material. Magnetic field becomes less dense inside the material. Let me explain this. You all know that it is always repelling the forces when suppose this is a substance or you can say diamagnetic substance. So what it will do? It will try to repel the things. So it will not try to allow the magnetic field to pass from inside it. What it will do? It will try to, suppose this is one of the line of magnetic field, it will allow only one. Then what will happen? It will try to repel other. It will try to repel other. So यहाँ पे क्या हो रहा है? It is trying to repel, which means the magnetic field inside the material is very less. Here you can see in this much part there are 5 lines, whereas in this part there is only 1 line, which means that magnetic field inside the material is very less dense. Okay, I hope this diamagnetism portion is very clear to you. So keep studying, make the notes of it. Thank you students, have a nice day, keep studying.